Good day, students. Now we're here today to discuss electricity, the topic of electricity, and also the introduction of electricity and magnetism. Now, at this point in the syllabus, you should have covered understanding what atoms and all different states of matter. Now, by now, you should understand that all matter contains positive and negative electric charges. And we should know that the positive charges are situated within the nucleus of these atoms, and the negative charges are situated on the energy shells circulating the nucleus. Now, we will also have knowledge of that in liquids and gases, the positive and negative charges can be mobile. However, in metals, the negative charges, which are the electrons, can be mobile, and the positive charges, they remain fixed within the nucleus of that material. Now, what we're going to learn now in terms of bodies, we're going to understand that bodies can be referred to as being charged or being uncharged, in a sense of saying that they are neutral. Now, we see that neutral bodies have the same amount of positive and negative electric charges, and therefore meaning that they can cancel each other out. Right? So meaning that they have the same number of protons and the same number of electrons. Good. Now, a body can become charged, meaning that if they either gain an extra electron or if they lose an electron, right? And one of these things we could learn by the process of static electricity, where we have electrons can jump from one surface over to another surface of a body, right? So then a neutral body can become positively charged, or a neutral body can become negatively charged. In that case, a neutral body can become positively charged by losing an electron, right? Whereby it now has majority of positive charges compared to the number of negative charges. And then next, a neutral body can become negatively charged, whereby it can gain extra electrons. So what happens now, it has more electrons than protons. Now, one of the things that you would have learned as well is that electrons and protons have the same magnitude of charge, as in the same size, same amount of charge. They pack the same punch. However, they did very much differ in mass. Good. Now, what we're going to start to look at is how can a neutral body become charged. One, we learned that a neutral body can become charged by the process of friction. Now, what you would have learned about friction is that friction is when one surface rubs over another surface, right? So in this case, we're saying if two surfaces are rubbed together, that one of these, it can cause a neutral body to become positively charged by losing an electron, or another case, you can rub a material onto a neutral object and it can become negatively charged by gaining electrons. Okay, so that's the case of the process of friction. So in the case of a glass rod and a cloth, a glass rod can become a neutral glass rod. So if you have a glass rod and we rub it with a piece of cloth, so we rub that piece of cloth over it, and this cloth, let's say the cloth is initially negatively charged, that this cloth can help to cause this glass rod to become positively charged by attracting all of these electrons. Electrons travel over to it and make it become positively charged, because it now has more positive charge than a negative charge, right? So basically that's the process of friction. So it causes charges to jump off of a surface, right? So all of this is we're referring to is looking at static electricity. Good. Now, just taking a step back, electricity, the term electricity is basically the movement of electric charges. That's what I want, that's one of the things that we need to understand, that electricity is the movement of electrons. That continuous movement of electrons is what is referred to as electricity. Good? Now, so one, we said that static electricity can occur due to the process of friction, right? Or charging by friction. Now, so we have a glass that can become positively charged by rubbing a negatively charged cloth over it. Also, in this case, we could have a polythene rod. Suppose we have a polythene rod, a neutral polythene rod. Right? And we're gonna take the same cloth that's negatively charged. Good? Or let's say this cloth is positively charged. Good? And we're going to rub this cloth over the polythene rod. Now, as we rub this cloth over the polythene rod, now what happens is that as a result, the polythene rod can become negatively charged. Because with this positive charge, the excess negative charges inside the cloth can then jump over to the polythene rod. So therefore it now has an excess of negative charges, hence resulting in it becoming negatively charged. So I want you to understand that. We'll take it one step at a time. That it can become negatively charged by having more negative charges than positive charges. It has more negative charges than having more positive charges. Right? So this is due to the process of friction. Another process in which a neutral object can become charged is by the process of induction. Right? Now, induction follows wherefore you're looking at charges finding somewhere to move. They're going to be moving away from each other. Now, the reason these charges move are based on their physical properties. Right? And for electric charges, they follow two simple properties. One, first property of electric charge is that like charges repel. Like charges repel each other. What does that mean? It means that a positive charge is going to push away a positive charge. Right? So it means a positive charge, meaning a proton, is going to repel another proton. They're going to push each other away. They're going to repel. Same thing with an electron. A negative charge, they're going to repel each other. Good? Second property is that unlike charges, attract to each other. Now, what does this mean? Right? What does this mean? Unlike charges attracting each other, means that a positive charge is going to be attracted to a negative charge. A positive charge is going to pull a negative charge in it. Right? So they're going to be attracted to each other. Good? And therefore, it happens vice versa. So a negative charge is going to be attracted to a positive charge. Good? They're going to pull each other inwards to each other. So this is the main concept that helps to introduce another way of making a body become charged due to the process of induction. So that's what we're going to look at. We're going to understand what happens due to the properties and how it leads to the process of induction. So just a reminder that the main two properties of electric charges, that like charges repel and unlike charges attract. Good? And just remember that there are only two types of charge that exist: a positive charge and a negative charge. Positive charge also referred to as a proton, and a negative charge also referred to as an electron. Good. Next. So we're going to look at now the process of induction. Now, if you look, when you look into the notes, when you talk about charging by induction, it basically tells you that there's no physical contact in this process between a charged object and an uncharged object. Right? Now, the aim is that we want to make an uncharged state of matter charged. We want to make an uncharged solid charged. Now, in order for this to happen, we need to bring a charged object very close to it. And the being in close proximity to each other, it causes something to happen within that neutrally charged body, right? And that is due to the two properties that we just learned about like charges repelling each other and unlike charges being attracted to each other. Now, in the case of induction, what you're going to need is that any charged object that you bring next to an uncharged surface is going to cause it to become charged of the opposite nature. So it means now a neutrally charged body, in order for it to become positively charged, you need to bring a negatively charged object next to it. Good? I'll repeat that. For a neutrally charged object, in order to make it positively charged, you need to bring a negatively charged object next to it. Now, there's a key element in charging by induction. Charging by induction needs a process known as earthing, right? Earthing is whereby you creating a direct flow for charge to flow from or towards earth, right? Where earth is a big storage unit, where it is basically a big neutrally charged object, right? Where it stores up negative charges, or it can emit out negative charges. So for instance, if we have a neutrally charged sphere on an insulated surface, so we have a neutral sphere on an insulated stand. Now this neutral sphere um, has equal number of positive charges and negative charges, right? It has equal number of positive and negative charges. Now, if we were to bring this neutrally charged sphere next to a negatively charged rod, if we were to bring this same sphere next to a negatively charged rod, what do you think is going to happen with these charges inside there? Based on the properties we just learned, something is going to happen to these charges, right? So we learned just now that negative charges are repelled by negative charges, and we also learned that negative charges will be attracted to positive charges. So it means now that these charges inside the neutrally charged sphere are going to realign themselves, right? Now, generally, we know that particles in a solid don't just move like that. But we want to understand the physical nature of what happens in terms of the charges. Now, it means now that the positive charges, just going to imagine that the positive charges are going to be attracted to the negative charges in this negatively charged rod. So the positive charges are going to realign themselves this way. Now, negative charges are going to be repelled from these negative charges, and they're going to try to go to the furthest point from it. Good? So we have 3 protons, 3 electrons. Right? It is still, at this point, the sphere is still neutrally charged. Now, if we take this rod away, the, the sphere is still neutrally charged. But our aim is to make this sphere become charged, whether it becomes positively charged or it becomes negatively charged, right? That's our aim. We want to make it charged. Now, as we mentioned, that if we bring a negatively charged object next to the neutrally charged sphere, then this is going to become charge of the opposite nature. So a negatively charged is going to make this positively charged. Good? So we want to see how does it become positively charged. So as I remember, I mentioned a minute ago that the key element in charging by induction is the term known as earthing or grounding. So we want to earth the charges. Now, in this case, earthing provides a direct path for charges to flow from this neutrally charged object towards Earth. Remember, it cannot pass through here because we said here that it's an insulated stand. Insulated meaning that it doesn't allow charges to pass through it. Good? So in this case, we are allowing an avenue in which charge can flow. Good? Can either flow from the object to Earth or from Earth back to the object. Right. So now, in this case, we're saying that we're going to earth it. Whether we touch it with our finger, that the charge can flow through your body towards Earth, or we touch it with some other material. Now, in this case, it's like opening a window. So somebody wants to get out of a house, the door is locked, we can jump through the window. So that's what earthing is doing. It's allowing a direct avenue for the charges to flow. Right? So at this point, just for a brief second, when we touch this sphere, that you're going to have the negative charges are going to flow out from the neutrally charged sphere and down towards Earth. Good? And by the time when we remove this, what remains in there are the positive charges. Right? Maybe not all of the negative charges might go out, but majority of them go out, and you have an excess of positive charge. You have an excess of positive charges in it. So then this is now a positively charged sphere. Even if we remove the negatively charged rod, let's just leave that off for now. Even if we remove the negatively charged rod, this is still positively charged. So in conclusion, what we looked at today is looking at the presence of charges in materials and how a body can become charged. And we're saying that a body can become charged by 2 different processes, whether by the process of charging it by friction, where you have a cloth rubbing over some material and there is direct contact, whereby the negative charges can either jump from one surface over to another, leaving the object to become positively charged, or by the process of induction, right? That you could have bringing 2 surfaces very close to each other and providing a direct avenue for the excess charge to flow using the 2 properties that we just learned about, which are the properties that like charges are going to repel and unlike charges are going to be attracted to each other. Good? So that ends the first class for now. We're going to move on to something in the next class. All right?